So hey guys, today we will look upon another wonderful question. So this question involves the combined loading case. So it is given that a rectangular strut of this is the width of the strut. This can be called B and wide, and it is 120 thickness. Okay, so let's call it T. Okay, it carries a load of 180 kilonewton which is acting at an eccentricity of 10 mm. So we can see it is not directly acting upon the neutral axis. So we need to shift the force. This is the force acting 180 kilonewton to the center of gravity, that is along the neutral axis. Along the neutral axis. So how can we do this? So wait, let's make the cross-sectional area. Okay, so this we can see this is the central neutral axis. We will shift the force. So when we shift the force, so the force acting will be 180 kilonewton, but it will along with the force, a moment will also act along this direction, and the value of this moment will be given as m is equal to force into perpendicular distance. And what is this perpendicular distance? 180 kilonewton into it is 10 mm. Okay, so we need to convert into the SI unit. So it can be written as 180 into 1000 into 10 by 1000. So this will be the moment acting, its value would come out to be 1800 Newton meter. Okay, so now we can proceed to solve the what we need to find. We need to find the stress acting at the section. Okay, so how the bending stress? So the maximum intensity of stress that can be written as maximum stress intensity, that is sigma max. It will be the summation of the bending stress and the force acting, that is the normal stress acting. We can call it as the compressive stress. Okay, so this sigma max. So how the bending stress is given? The formula is sigma is equal to my by I plus, and it is simple, force per unit area. So moment we found out earlier, so it is 1800 Newton meter, and this we can write what is y. We need to find the y. So how can we write y? So y is equal to this will be the y. Okay, at an eccentricity sigma is equal to my by I. So y will be r 75 mm. Okay, and I will be bh cube by 12. Okay, first my by I, and this is force per unit area into 1000. Area is given as b into h, and this I am writing as h. So first we will write y. Okay, so y is 75 mm, and this will be our h is given as b is at 150 and mm, and h is our 120 mm. Okay, we need to put the values in the SI unit, and we will find out the force stress. So directly, and this is bh cube by 12, 150 h cube by 12. So y is actually, what is y? Y is actually h, that is bh cube by 12, but here this is our y. Okay, bisecting the section intensity at the section. Okay, so this will be our y. So this we can write as 75, and you need to convert into MPa, and we will do this. Uh, this is to the power 4, and if it is square, then Newton per square, that will come as MPa. Newton per square is equal to MPa. So rest 2 we need to calculate. So you solve the required, you put the values into 10 ki power 6. Okay. Other in it will come as 10 ki power minus 12 minus 6. So this square, rest square, I am shifting it to upward direction. Okay. So I'm erasing this calculation part, and this this will be our force 1800 into 1000 on B into H, and this is directly our square. It will come, so no need to convert it because it will come out to Newton per square. So this, after solving, we get as 4 plus 10. Okay, and after this we get it as 14 Newton per square, which is our 14 MPa, and this will be our correct answer. A will come out to be. So the calculation part, you can easily solve it. I'm not focusing on the calculation part, but our focus. What is our focus? Focus is our combined loading part, है ना? So how we shift the force, shifting of force. It is one thing. Moment it will come combined loading case. So this came in 2019 ESE. Okay. So this was a wonderful question. How to deal upon the combined loading case. Okay, guys. Thank you.